In this video, I'll be working through all the questions from the Summer 2025 Cambridge A-Level Maths Exam Paper 2.2 and 2.3. They're the same paper with the same questions. It's going to be a long video. I don't want to just give you the solutions. I am trying to teach you how to do these questions, and that takes time. Remember, we're not in the classroom, we are on YouTube, so take advantage of their tools. You can find chapters in the timeline to jump to the question you're interested in. Also, remember to pause and rewatch difficult parts of the question. Then we can change the speed. We can speed it up or slow it down as you need. Okay, let's jump into question 1. In question 1, we're given an integral here, an equation with an integral in it. We're told this integral is equal to the natural log of a. And basically we're asked to find a. So what you want to do is do this integral. Get a number for that and have that equal this, hopefully solve for a. So let's jump into doing that. Lots of students will be able to do this integral mostly in their heads. It's a fairly standard looking one. I'll do it a little slower. I'll use substitution. I'll show you the shortcut as well. Point out where you could save time in a bigger question. But we have plenty of time here. Let's do it nice and slowly. This integral, what makes it difficult is this bottom row. So if we substitute that, u is equal to 4x plus 1. If we substitute that and do this again, this integral will become, let me leave the numbers out for a moment. I'll talk about that in a moment. 8 over u dx. So that's a problem. dx is a problem. I need to know what dx is. To do that, we differentiate this guy. du dx. There's a dx appears. And this is equal to 4. The derivative of that. And rearrange that so dx is on the top. We'd get dx is equal to a quarter du. That's good. I can now replace this guy. Let's replace him here. 8 can come outside as well while we're at it. 1 over u. Instead of du, I get 1 over 4 du. Instead of dx, I get 1 over 4 du. Again, this 1 over 4 can come outside. 8 over 4 is 2. 1 over u du. This integral is nice and easy to do. The answer to this integral, 2 is obviously out here, is just natural log. Because we're given that in our formulas. The integral of 1 divided by something is the natural log of that something. So it's just natural log u. Now I've left out a lot of numbers here because I wanted to, because there's 2 ways to do it basically. At the very end here, you can just change this now back to 2 natural log 4x plus 1. And this is evaluated at, this guy's evaluated between 11 and 2 because there's x's. This 11 and this 2 are talking about what x is equal to. Here I can write 11 and 2 as well because it's dx. We're talking about the x still. This one I can't. There's no 11 and 2 here. It's not 11 and 2 here, and it's not 11 and 2 here. You can ignore these if you want. Use this as your ending. Get your answer out here. I'll do the answer twice. Yeah, let me write this one again here. 2 natural log 4x plus 1 between 11 and 2. And I'll also do 2 natural log u between some numbers here. What those numbers are, it's easy enough to find. When x is equal 11, what is u equal to? 4 11s is 44, plus 1 is 45. And when x is equal to 2, what's u equal to? 4 2s are 8, plus 1, u is equal to 9. This is between 45 and 9. 45 and 9, 45 and 9, 45 and 9. These will give the same answer, these two. 2 natural log, put 11 in, we get 45. This one we got 2 natural log, put 45 in, 45. We get the same answer, minus 2 natural log 9 minus 2 natural log 9. Same answer, whichever you do there.
If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below.
Let's get back to the question. This is our answer here. I'll write just one of them because it's the same answer. 2 natural log 45 minus 2 natural log 9 is all equal to natural log A. We still just need to solve for A. You'd love to cancel the natural logs, but that's not how it works. You need the natural log all in one place. Also, these 2's here, they're trouble for it. So that's the first thing you need to do. You need to get rid of these 2's. The rule for logs tell us that this 2 outside is the same as natural log 45 squared. Again, this 2 comes in as well. It's natural log 9 squared equals natural log A. We still can't just cancel natural logs. Natural logs don't work like multiply, I'm afraid. We need one natural log either side to cancel it out. But there is another rule for natural logs, or any logs, when they take away like this. This is the same as saying natural log 45 squared divided by 9 squared equals natural log A. Now the natural logs do cancel. Well, what we're really doing is putting both of them to the power of E, and that's what's destroying them. But you can think of just what's in this natural log must be the same as what's in this one. So that's an A, not a 9. Just put this in your calculator. 45 squared divided by 9 squared is 25 according to my notes. So A is equal to natural log 25. And that's your answer for question 1. If you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day. In question 2, they give us 2 different equations here and one is to sketch them on the same graph. Now, hopefully you're able to do this quite quickly. I'm going to do it really slowly because I'm trying to teach you how to do it. Let's start off with the harder one, I hope anyway. The absolute value one here, 2x minus 9. What does the absolute value do? Let's make a nice big graph here. To draw one of these, just ignore it for the moment. What the absolute value does is, if it's positive, it does nothing. And if it's negative, it changes the sign of everything. So let's just look at this when it's y is equal to 2x minus 9. Let's draw that picture first. Minus 9, that's the y-intercept. So we'll put that down here somewhere at minus 9. And 2x, that's a slope, a positive slope of 2. So it's going, let's put in a dotted line like this. That's what 2x minus 9 looks like. It's not what they want us to draw, though. They want us to draw 2x minus 9 absolute value. Now, remember what that does. When it's positive, and this is above here is positive, when y is positive, or when this is positive, so that's above this line, absolutely nothing changes. So let's fill that in. When it's negative, though, everybody's sign changes. So at minus 5, it becomes plus 5. At minus 9, it becomes plus 9. So we'll put 9 up here. And it just bounces like that. That's how you draw a absolute value. You draw the positive part and it just bounces. It just mirrors off it like that. What the examiner wants to see here is this 9. I don't think they need to see this minus 9, but they also want to see what this number is here. So do remember to solve this for 0. So put a 0 in for y. Same here. 0 doesn't affect the absolute value. And we just solve this. 9 comes over. Well, let's do it here. 2x equals 9. X is equal 9 over 2. That's about 4.5. So let's just put it in here. 9 over 2. Sorry, I said about 4.5. It is 4.5. Okay, that's that one drawn. This one should be a lot easier because there's no absolute value. It's 4x minus 5. Go to minus 5. That's the y-intercept. Be about here, I suppose. You don't have to draw these too well at all. A sketch just has to be a rough drawing with a few numbers in. 4x, that's much steeper than this. If this is 2x, I want twice as steep. So I'll go up like that. Stay going like that. That's a simple. That's all they want. With one more thing, they do want this number here. this number would be 5 divided by 4. That's 5 over 4, or 1.25, 4.5. That's our rough drawing. That's our answer to part A.
In this video, I'll be working through the question you can see on the screen here from the summer 2025 Cambridge A-Level Maths papers 2.2 and 2.3. They're actually the same paper. I'm going to try and show you how to do this question and not just the solution. So definitely pause and rewatch certain parts of the video as you need to. If you are looking for a different question from one of these papers or a different paper entirely, you should be able to find a playlist in the description below. If you can't, have a look around in my channel. Okay, let's get into the maths.
For part B, they give us this inequality here, which is just the two numbers or the two expressions we had in part A. And they ask us to solve that. You can do this without any drawings if you want. I won't bother doing it now because they clearly want us to use the drawing. But it's much easier to use the drawing because we can get rid of the greater than or less than. We can get rid of the absolute value and just put equals down if we have the drawing and we use our brains a bit. So let's look what this is saying. The absolute value one. I wish I had different color pens, but they don't show up too well on camera. But this absolute value one, this phi-shaped one here, is less than this line here. When does that happen? So let's have a look at it. This is above it. It's above it, above it, above it, equal it, below, 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 below. And this says they diverge as they go on. So really what we're looking for is this number here, this x value here. If I know what that is, the answer is just when x is bigger than that. Everything over here is the answer to this. So all they want to do is find what is this number? What is this number in here? So you can throw away a lot of what they give us. What they're really asking for is when is this line, 4x minus 5, when is this line equal to this line here? So what is this line? It's the minus part of this guy. It's minus 2x minus 9 plus 9. So basically, when are they equal each other? That's how I get this point. Move that across, we get 6x equals, move this across, we get 14. X is equal 14 over 6, which is the same as 7 over 3. That point in there is 7 over 3. The answer to this whole question is x is bigger than 7 over 3, because that is when this is less than that. Hopefully you see where that comes from. If you're wondering, you would have got full marks for part B if you also just did when is this bigger than this number, and then split it in half. When is this bigger than the minus of this? Equate them out. We'll find out it's always bigger than the plus part, and we'll find out it's bigger than the minus part between this number and this number. So if you did it out by hand, that's what you'd find. X is between 7 over 3 and 9 over 2, and x is bigger than 9 over 2. Putting them together, you get this. Okay, hopefully that helped you with this question. That's it for question 2. Thank you for watching. Have a great day. In question 3, we're given this equation here, but we're then asked to find the stationary points for this curve or this equation. When you see stationary points, I really hope you start thinking dy dx equals 0, because that'll probably get you one of the 5 marks just writing that down. Don't guarantee that, but it'll certainly get you a long way there, because that's what you need to do here. You need to differentiate and then put the derivative equal to 0. Differentiating these 3 terms, 2 of them are easy. These 2 are nice and easy. So it really comes down to how do we differentiate this one here. What we have is 2 things dividing each other. So hopefully you're thinking quotient rule. So the dy dx is equal to, the quotient rule tells us when 2 things divide, we take the bottom row. This formula is in your formula table. We take the bottom row and leave it alone, 2x plus 3. We multiply that by the derivative of the top row. Differentiate just the top row is 8. So multiply that by 8. Then take away the top row left alone, multiplied by the derivative of the bottom. And that's just 2. And we divide all of that by the bottom row squared. So 2x plus 3 squared. That's the derivative of this guy. So many students then just forget these two terms. You're throwing away a few marks. Your answer then comes out all wrong. If you do all the work right, hopefully the examiner only takes 1 mark away for that mistake. But sometimes they take more just because your answer is then wrong and they're too lazy to check why you're wrong. The derivative of minus 6x is just minus 6. And the derivative of 5 is 0. So it doesn't even go there. And remember, we know it all equals 0. We have an equation with one unknown. We can solve this and find our coordinates of the stationary points. So we're getting 2 answers. Okay, how do you do this? Well, let's clean it up first. This top row here, we have 60. Well, let's write it all out. 16x plus 24 minus 16x all over 2x plus 3 squared minus 6 equals 0. These 16s cancel. We're just left with 24 up here. So what do? We move the 6 over and we multiply. Well, let me do it a little slower. I don't want to confuse anyone. We get 24 on this side equals 6. This is 2x plus 3 squared. I've just moved the 6. I've added 6 to both sides. Next up, let's multiply both sides by this bottom row. On the left side, it'll disappear and it'll reappear on the other side, is often the way most students think of it. We just multiplied by this. It destroyed this side. It appeared over here. This is going to be a quadratic if we multiply it out. We just need to multiply this out, though, at this point. 24 is equal 6 times, let's see, that'll be 4x squared. This by itself. 3 times 2x plus 2x times 3. That'll be 6x plus 6x. That'll be 12x. And plus 9. Okay, you could multiply 6 in if you want. Get nice big numbers here. You're going to end up dividing by 6, though, again in a moment. Just divide 6 now. Both sides divided by 6. This becomes 4 equals 4x squared plus 12x plus 9. If we move the 4 over or take 4 from both sides, we get 9 minus 4 is 5. That's a quadratic, equals 0. I've moved the 0 as well. I hope you don't mind.
If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below.
It's a quadratic. If you're not good at factorizing quadratics in your head, that's fine. Use the minus p formula to solve this. But the only way to get 5 is 5 by 1. So we have a few choices there, 2 by 2 or 4 by 1. Have a think, play around with it and see which gets 12x. 5 times 4 is too big. So it's 5 times 2, that gets you to 10. And 1 times 2 gets you to 2. So 10 plus 2 is 12. So it's 2x and 2x here. Check the signs. We need 10 plus 2. So we need both of them to be positive. And that gets a positive 5. So your 2 answers here for x is equal minus 5 over 2. Remember, this is equal 0, just rearranging. Or x is equal minus a half. Again, a lot of students leave this as their answer. Once again, you're throwing away probably 1 mark at this point. Let me squeeze the final answer in up here. Oh no, I guess I don't have that much room to squeeze it in. Remember, we still want y. So if x is minus 5 over 2, what's y? Y is equal to all of this. Let me write it out once. 8 multiplied by minus 5 over 2 over 2 times minus 5 over 2 plus 3 minus 6 times minus 5 over 2 plus 5. Do all that out by hand or do it on a calculator. It's not too bad to do in your head. Like 2 goes into the 8, 2 goes into the 2, things like that. We'll get 4 times, we'll get minus 20 on top. we get minus 5 plus 3, minus 2 on the bottom, so that's plus 10. Let me write that out. Plus 10. The minuses cancel. 2 goes in. 3 times 5 is 15, plus 15, plus another 5. We get 30. But again, do that on your calculator. So the answer for the point, let's put it in. I don't want to rub the board out and take more time. But one of the points would be minus 5 over 2 and 30. That'd be one of your answers. Do the same here for a half, minus a half. Put it into everything. Put minus a half in everywhere. And I'll just check my notes now and see what you get. I think it's 6. 6. Minus a half and 6. These are your two answers to question 3. Hope you don't mind I skipped it. It's just filling in the numbers to that equation. Okay, that's it. If you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day. In question 4, they give us 2 different equations and they draw their picture. I've just left it off. I want to make clear that it's 2 different images we're drawing out, or 2 different graphs. One looks like this and the other looks like that. And that means they cut off a certain area here. We're going to need that in part C, I believe. First thing they want us to do is this point here. It's P. Yeah, they've given us the x coordinates of this point, but they just want us to get it again. It's only 1 mark, so it's not a lot of work here. The point of intersection. It's just when these two equal each other. Oh, that's one thing I just wanted to point out. Which curve is which? You might not know, and you don't have to know. It will make a slight difference in part C. Your answer might come out as a minus if you get it wrong, but because you're getting the area, hopefully you would know to change it back to a positive. But we do know what E, the shape of E, looks like. It looks like this. Minus, when there's a minus up here, it goes back to this shape. 2x would just make it a bit higher, and 4x would make it just a little higher as well. This guy here is that shape. So I know this one is this guy, and sine would make it probably wave around as it goes down here, but that's part of a sine. Not important. Let's go on to part A. Put these two equal to each other. We get 4e to the minus 2x is equal 1 plus 0.5 sine 3x. They've given us the answer. It's, well, you can see it yourself probably, but it has 2 x's in it. This has 2 x's in it. They want you to get x equals. They want you to rearrange and get x equals. You have 2 choices. You could get this x on its own or this x on its own. Which is the correct one? Hopefully it's clear, because the answer they showed you has sine 3x still in it. So you don't want to mess with that. Leave it where it is. It's this one they want. The other clue is the answer they give you has a natural log. That natural log will appear when we're destroying this e here. So hopefully that's where you see that's where it all comes from. Okay, let's get rid of this 4 first of all. 1 divided by 4 is, I'd usually write 1 over 4, but their answer has 0.25 in it, so I'll leave it the way they do it. 0.5 divided by 4 is 0.125 sine 3x. We're already close to the answer they wanted. How do you get rid of e? Get natural log of both sides. Destroys that e, and a natural log appears this side. Again, it's now looking very much like what they gave us. And divide both sides by minus 2. I'll leave it down here. X is equal minus 0.5. So 1 divided by 2 would appear over here, which is 0.5. So that's a 5 of natural log. I hate writing out these long things. I also hate editing it. So I better just write it. Okay, that's the answer to part A. That's what they wanted you to find. It wasn't too hard, not too many steps.
If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then, if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below.
In part B, they want you to use the iterative formula from this equation here to find the answer, find out what the exact point of intersection is here. To give you more information, tell you like they want 6 significant figures on each step, and your final answer should be 4 significant figures. This question comes up every year, so you've no excuse not to be able to do one like this. They change slight things from time to time. Like they haven't given you the iterative formula. You need to know to put a n plus 1 here and an n here. Or as some students put n and n minus 1. It's the same thing. It's fine. You need to know the steps to doing it. You need to make a first guess. They've given you the initial value, the first guess. I call it x0 or sometimes x1. Again, it's fine. 0.5, that's your first guess. How do you get the second guess? Well, if I've x0, I want x1. This will tell me x1 is equal if x0 is put in here. So I just put it all out, minus 0.5 times natural log of 0.25 plus 0.125. Where am I missing? Oh, am I missing a bracket anywhere? No. Sine times 3 times your previous guess, your x0 in this case. So 0.5. Put all that into a calculator, you'll get your answer. At this point, I like to tell you guys of a nice tip. This question only goes on 3 times, so you have to do this in your calculator 3 times. Not too bad. But sometimes the last question I did was 11 times. Really annoying. There's a nice little shortcut you can do if you learn to use your calculator a little bit. On your calculator, if you put in 0.5 equals, that's it. Your calculator now will remember that your previous answer was 0.5. Next, on your calculator, if you write this whole line out carefully, you need brackets, you need to be really careful. You need to do it all in one piece. But instead of 0.5 here, if you put in answer, it's a button on your calculator. What your calculator will do is it'll do this equation and put the previous answer in. And you get the answer. You haven't saved anything yet. But then if you press equals another time, it will do the same equation and put the last answer in, which will be this one. You'll get x2, x3, x4. You can get them all by just pressing one button. Anyway, let me just write out the answers you will get. If you put this one in, x1 would be 0.490832. That's 6 significant figures. One bit, a nice little cheat in the exam is if they ask for 6 and you're not good at rounding off, you're worried about making a mistake, just give 7 or 8. I think you get full marks. And hopefully you guys are able to round off. That's rounded off to 6 significant figures. I then underneath like to write out 4 significant figures, because you know you get to the answer when your 4 significant figures repeats itself. Okay, again, you press equals in your calculator, you get the next number. If you want to do it the slow way, you just do all this again and put this 6-digit number in there. Or use the memory of your calculator, because our answers might get slightly different, I guess, if you don't use the memory of your calculator, because you're rounding off too much. Either way, what you should get is 0.491220, I think. I have a bit of a typo here, so that might be wrong. 4 significant figures there. These do not repeat yet, so that we're not at the final answer. x3 is 0.491201, which 4 significant figures is 4912. This does repeat. If you stay pressing equals, you stay doing this, you're not going to get closer in 4 digits at least. You'll get more exact in 6 digits. You get more exact in 8 digits, but 4 digits, you've done enough. This is your final answer for part B. Now that feels like it should be enough for question 4, but they do add on 4 more marks, so a pretty big question. They want you to find the area of this shaded region here. Hopefully that sparks bells in your head. The area of a region where a curve is integration. So what we want to do here is integrate. Integrate gets the area under a curve. So you could get the area under this one, and take it away. But again, hopefully you remember to get the area between two curves, we take the top curve. What was that again? That was 4e to the minus 2x. I've rubbed it out. The integral of the top curve, take away the bottom curve. So that was 1. So take away 1. Take away 0.5 sine 3x. So the integral of this. And what we've learned from part B, though, is what units to put in, what limits, sorry. It's between 0, obviously. But where does it go up to? That's what we just found out. What was it? 0.4912. You could use 6 digits to 7 digits, but they were obviously happy enough with 4 digits because their final answer, they want 2 significant figures. Let me put it in here, 0.4912. Okay, it's already quite a long question, so I will do these integrals quite fast. We're going to use substitution in them, but I'll do that in my head, as it were. So what I mean by that is the integral of this here, 4 is ignored, left alone. The integral of e to the power of anything is just e to the power of anything. We just leave it alone. That's how you integrate e. Unless what's up here is complicated. And it is quite complicated up here. It's not just x. So what we've done there is substituted it out. If you were to substitute minus 2x, you would end up differentiating it and get 1 over minus 2. And that would end up multiplying back in. So we can do all that in our head. Basically what it is, we integrate this as if it's simple. That's what I've done there. And then we divide by the derivative of up here. So we end up dividing by minus 2. If the derivative of the complicated thing has an x in it, it doesn't work. Because if you go through the substitution steps, it wouldn't work out. You'd end up having an x back in your integral. Okay, so hopefully that's clear. I think most students are happy. They've learned the shortcuts of doing these semi-difficult equations. So the integral of minus 1 is just minus x. The integral of this, the minus a half, we ignore that. It's a constant, comes outside. The integral of a sine is minus cosine. So minus cosine 3x. The minus will cancel that minus. We get a plus. Again, though, this was complicated. This 3x is not an x. It's more complicated than that. So we end up dividing by the derivative of this. So we divide by 3. And all of this is evaluated between 0.4912 and 0. So we just put it in. I'll write it all out. We get minus 2e to the minus 2, 0.4912. Minus, we put, instead of this x, we put this number in, 0.4912. Plus, what's this? 1 over 2 divided by 3. So that's 1 over 6. Cosine 3 times 0.4912. That's just this guy put in. Then we take away minus, put in 0. That one's nice and easy, though. We get minus 2 e to the power 0, which is just 1. So minus cancel, get a 2. Anyway, put 0 in here, we get minus 0. Again, just 0. And then we get minus 1 over 6 cosine 3 times 0, or well, just 0 we'll write in. That's just 1. Cosine of 0 is 1. So that becomes minus 6. Put all this in your calculator. Just be careful. Just do it all in your calculator. Just be really careful. The answer I got was, and I have checked it, it is correct, 0.609484. That's dead going on. And they wanted 2 significant figures. So that's 0.61. One of the most annoying things about questions like this is you don't know if you're right. If you make a slight mistake doing this, maybe you got 0.82. How you don't know that's right or wrong. It's very difficult. If you got a minus number here, you should know you're wrong. If you knew which curve went over the other. It can be difficult. All I'd say is just be really careful. Check your work. Hopefully you have 5 or 10 minutes at the end of your exam. Often students have 20 minutes. Some questions you do fast because you know, some questions you can't do at all. So you save time everywhere in the exam. Hopefully you should have time to go back and check these questions. Just do them twice, 3 times. Anyway, that's it for question 4. If you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day. In question 5, we're given this polynomial here that's missing 2 pieces of information, A and B, and we're asked to find out what they are. To help us do that, we're given 2 clues. Those 2 clues are, they've told us that 2x minus 1 is a factor and x minus 3 is also a factor. Now, there's 2 ways to do this question. I tend to show one way that's a little easier, but I like to mention the other way because it's one of my favorite ways to do it. What you could do is divide each of these into this, and what you'd get, hopefully you remember how to do long division of algebra. You divide this in here, you'd get a longish mess, a little long mess, and at the end you'd have something A plus something B, and you know it equals 0 because there's no remainder if it's a factor. And you'd also get a bit of a mess up here, and you get that twice. These 2 bits of information in A and B down here is enough clues to answer for A and B. And what you get up here, the mess you get up here, is actually useful for the second part of the question. It's not that useful in this case though, so I won't show that way. The way I'm going to show is, if this is a factor, then we know when it equals 0, we can get the root. So yeah, let's put this equals 0. And move the 1 over, we get x is equal 1 over 2. This is a root of this polynomial. Just like the same here, x is equal to 3. These are roots of this polynomial. What that allows us to do is we can put in p half and know we're going to get 0 out of this. So if we put in a half here, half to the power of 4 is 1 over 16. A times 1 over 16, A over 16. Put a half in for each of these. We get B over 8, 13 over 4, minus 35 over 2, plus 15. And we know this all equals 0. We can clean this up a lot. Multiply everyone by 16. This becomes A. This becomes 2B. This becomes, let me just cheat here and use my notes. This becomes 52. This becomes minus 280. And this becomes 240. Yeah. Again, we can clean this up a little bit. A plus B. Move everything over the right-hand side. And we'd get minus 12, I believe. Let me just double check that. Yeah, looks about, about right, minus 12. Sorry, I'm missing something here, 2b. So that's one of our clues have given us this equation here, this equation with 2 unknowns. We put the second one in, we get P3, we put that in. Again, I'll cheat and use my notes. 3 to the power 4 is 81a plus 27b. And let's again cheat, plus 117 minus 105 plus 15 equals 0. Clean this up, we get 81a plus 27b is equal minus 27. Clean it up more, 27 goes into everyone. We get 3a plus b is equal to minus 1. There's 2 equations with 2 unknowns. We just have a simultaneous equation. I'll squeeze it in over here without rubbing anything off. A plus 2b is equal minus 12. This one, let's write double this one. We'll write 6a plus 2b equals minus 2. That was just to line up these 2 b's here. We can take one from the other. Let's take the top one away from the bottom. So basically turn the top one minus. 6a minus a, we'll get 5a's. They'll cancel. Minus 2 minus minus 12. That's minus 2 plus 12. That's equal to 10. A is equal to 2. And just put 2 back into either one of these, and you should get B is equal minus 7. That's your answer for part A.
If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below.
For part B, they'd like us to factorize the polynomial we had. But what a lot of students, I think, forget to do is we found A and B, so we should write the polynomial again. But this time we should put in the numbers 2 instead of A, and minus 7 instead of B. What were the rest? 13x squared minus 35x plus 15. So we want to factorize this. Remember, we already know two factors. We know 2x minus 1 is a factor, and we know x minus 3 is a factor. There's actually only one more factor, but it looks like there's two more. X, 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 and another x to get 4 x's. So we think we're looking for these two factors. Often when we're looking for two factors, though, we can just look for one quadratic and then separate that later. Again, spoiler alert, but we won't be able to separate out this quadratic. So how do you do this? There's a couple of ways here. Again, you could divide factors in, although the easiest way would be well, everything I'm going to do is going to multiply these two together. So let me do that. Two factors multiplied together is also a factor. X by x is 2x squared. Let's see, minus x minus 6x, there's minus 7x's there, and minus 1 by minus 3 is plus 3. This is also a factor. So to find the other quadratic here, let's leave this as 2. To find the other quadratic here, you could divide this into that. That'd be perfectly fine. I find it's a lot easier than that, though, if you think it through a little. There's some sort of quadratic here, something x squared. What has to multiply by this guy? This multiplied by this guy has to equal this. So what has to be here? It has to be 1x squared. So you don't need to do any maths really. We just know there has to be just 1x squared here to equal up here. And it's the same for the last number. 3 must multiply by something to get 15. It must be a 5. The only thing we don't know is the middle number here. Just call it some letter if you want. I'll use CX in this case because we used A and B earlier, but any letter you want really. And how do you find this? Well, these combine to make these three numbers here. We've used these two, and they're not involved in CX. That's how I was able to do it in my head. But CX here is involved in all three of these. So you just pick whichever one you want, and we can solve this. Another spoiler though, the middle one's a little harder. It's a bit more complicated. There's multiple C's involved. And all of them work. I'm just going to use this one here, minus 35. How does minus 35x, how does that come to be? How does these two multiply to get this? 2x squared can't multiply by anything to get an x. So he's not involved. Minus 7. Minus 7 is involved. Minus 7 must multiply by, plus there. Minus 7 multiplied by this number. That would help get this. And that, in fact, is minus 35x. Won't always look like that. Because there's another option. 3 could multiply by this one. And that'd be 3cx. We just solved this for x. All the x's cancel. So we don't even have to write them in to begin with. In this case, 35 and 35 cancel. Add both sides. We're left with 0 equals 3c. And we're left with c is equal 0. This is a special case, this one. It turns out the number that was here is 0. So the answer to this question, well, is that. Let me write it out, though, one more time. Let me just rub it out there. That's your answer. X squared plus 5 is the other factor here. Usually, you would have to separate this out, factorize x squared plus 5. You can't, though, unless you're willing to use complex numbers, which isn't in paper 2's curriculum. So you're not able to factorize this. That's as good as you can get. The three factors are this guy, and this one here. That's your full marks for part B. For part C, they want us to find the least positive value for something. Forget about that for a moment. We'll deal with that in the end. All that means is there's going to be multiple answers. They just want a specific one. What they want you to solve is P of cotan of 2 theta equals 0. Well, the first thing I'm going to do is I don't use cotans or cosecs or any of those. So I'm going to change this to just 1 over tan of 2 theta. That's all they're asking. Okay, so how do you solve this? There's only 2 marks for this, so it's not actually a lot of work involved. What they want you to, at this point, notice, the answer to this is the same as the answer to px equals 0. Just replace x with 1 over tan theta. And when this equals 0, all 3 of these equal 0. So the answer, we know the answer to this. It's x is equal to a half. Sometimes it's x is equal to 3, or it's x squared is equal to minus 5. And this one here has no answer. There's no answer to x squared equals a negative number. So that one's gone. So there's only really 2 options in this. Instead of x, though, we can write 1 over tan 2 theta must equal a half, or 1 over tan 2 theta is equal 3. They're the only 2 options. We can rearrange both of these. We'd get tan 2 theta is equal 2, or tan of 2 theta is equal to a third. You could just go ahead and solve both of these, and then you need to worry about the least positive, because you get infinite answers for both of these, but half of them are negative, so you can throw them away. So you're just looking for the smallest answer of all these. Shouldn't be too hard to do at this point, but I will just make it a little more complicated by drawing this. It's always good to draw. A tangent of something looks like this. Continues on, looks like this. Okay, there's multiple answers here. When tan 2 theta equals 2, I'll say 2 is here. Lots of answers here. Infinite answers. We don't care about this one, even though we still have to divide by 2, remember. This is going to be a negative, so throw that away. This one, even when we divide by 2 or divide by 2, this one's going to be the smallest. This is the only one I care about. For 2 anyway. But there's another option. There's a third that's here. Again, lots of answers. That's a negative, don't care. These are all bigger than this one, so don't care. So what's the very smallest one of all these? It's this one here. Let's put an X. Well, that's a bit confusing. This is the one I care about. This one is too big. The least positive value. It must be this answer here, coming from this question here. So you just go ahead and solve this. 2 theta is equal the inverse tan of that. Let's see, I have it here. 0.32175 divided by 2, we get 0.161 to 3 significant figures. It does it in radians, they want, don't they? Yeah, they do. Okay. So that's your only answer. You would also get an answer over here. I have it here actually. This answer would be 0.554. It's okay if you got both of these, but it's very important at the very end, you need to tell the examiner that one's not correct. You can do it by just putting an X through it, that's fine. The examiner at the very end needs just one answer, not 2 of them, because they wanted the smallest positive one. So this answer here, because there was, like this answer here would be, I guess, 90 away once you divide it by 2. I can't do that in my head, but there's many other answers. It's just, these are too big, these are too negative, and this one here is slightly too big. This one is the perfect one. Okay, that's it for question 5. If you have any follow-on questions, let me know. I'll do my best to answer. Thanks for watching and have a great day. In question 6, they give us this equation of a curve here where x's and y's all intermingled, so you can get some weird shaped curves. But part A, we don't need to worry about much of that. They just want us to show that there is no point on this curve for which y, the y coordinate, all that means is y is equal e to the minus 1. They just want to show that this is impossible. That's really what they're saying there. This is impossible. So let's just put this into this equation and hopefully we'll find something strange. We'll find like minus 2 is equal 8. Something that says this is impossible. Spoiler alert, it's going to be the square root of a minus number. That's what we're going to find when we put this in, and that's impossible, at least in this curriculum. Right, let's start off then. We rewrite this here with everything we know. X squared minus 3, it's just the y. Natural log of e to the minus 1 plus 6x equals 14. Now, natural log of e, they cancel each other. They destroy each other. So we're just left with a minus 1 in this part. Minus 1 multiplied by this is minus x squared plus 3 plus 6x equals 14. I don't need those brackets. This is a quadratic. We have an x squared, we have an x, and we have numbers. Let's just get everyone on the same side. I like to keep this positive. So everyone on the right will have x squares. We'll have minus 6x. We'll have a plus 14 minus 3. So we'll have a plus 11 equals 0. I'll move the equals over the right-hand side. All we want to show is that this is impossible. That's what you should be thinking here. Some students might think, oh, I just solved this, forget what they're doing. But when you're solving this, you'll hopefully find out, oh, this is impossible. Oh yeah, that's what they wanted you to show. So how do you show a quadratic has no solution? Hopefully you're remembering minus b plus or minus square root b squared minus 4ac over 2a. You don't need all that. This is impossible. The answer to this is impossible when what's inside here, b squared minus 4ac is less than 0. That's what you need to remember. When this is less than 0, impossible. Equals 0, only one answer. Greater than 0, there's two answers. That's what we have learned. So we know what b is, minus 6. So this becomes 36 minus 4 times 1 times 11. And that's 36 minus 44. That's minus 8. And that is indeed less than 0. And that's the answer to part A. This cannot be a solution because b squared minus 4ac is less than 0. There's no solution when you put that in. At least no real solution.
If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below.
Now, part A was sort of just a bonus question. It wasn't the real meat of this question. That's part B. In part B, they tell us about a point at 2e squared. So x is 2 and y is e squared. And they ask us to find the equation of a tangent to this curve at this point. Now, what does that mean? This curve looks strange. I have no idea what it looks like. Let's say it looks like this. I have no idea. I don't care. They're telling us this point is on it. Maybe it's right here. So we're given a point, 2e squared. And they just want us to find the tangent to this point. The equation of the line of the tangent to this point. So this question now revolves down to what's the equation of this line here? They just want you to find the equation of a line. You have the point. All we're looking for is the slope. What's m? We're looking for the slope of this line. Hopefully you're thinking, well, I know the slope is equal to the derivative. And that's what the meat of this question is. Find the derivative of this, or find, not the derivative of this, the dy dx. Find the derivative of y, at least. I guess you can say the derivative of this. How do we do that? That's what's difficult. There's two ways to do this. I'll set up the first way, and then I'll do the second way. Which is easier? One is shorter, but I'd say harder, and one is longer, but easier. All right, let me set up the longer but easier one first, and then you can finish it off if you want. I want to know dy dx. Let me just clear this off. I want to know dy dx, but To do that, it might help to find what y is equal. So if I rearrange all this, I'll find what y is equal. So natural log of y is equal to 14 minus 6x. I'll just move this over and divide by this, x squared minus 3. Get rid of the natural log then. Y is equal to e to the power of 14 minus 6x over x squared minus 3. That's y. This is one way to do this. All you have to do next is differentiate y. Differentiate this here. It's not too difficult. It's not as difficult as it seems. The derivative of e is easy. It's just the same as the question. It's just a chain rule. So you differentiate e as if this is a u up here. So I'll start writing the answer, I suppose. Dy dx is equal to e to 14 minus 6x over x squared minus 3. But the chain rule says then we need to multiply that by the derivative of up here. So really, you just have to differentiate up here. And that's the quotient rule. That's, let's see, the bottom row multiplied by the derivative of the top. I guess I can write it all out. X squared minus 3 multiplied by the derivative of the top. That's minus 6. Take away the top row. I hope I haven't got these the wrong way around. The top row multiplied by the derivative of the bottom, 2x, divided by the bottom row squared. That's dy dx. You might say, well, what do I do with all this? You could clean it up a little, but not much. Remember, you're just looking for the slope. Yeah, let me finish this off a little bit. Dy dx when x equals 2 and when y is equal e squared. You go ahead and put all of that in here. It's not as scary as it looks. 2 squared is 4. 4 minus 3 is 1. That's minus 6. That's, let's see, that's 2 times another 2. That's 4. Is that right? 16. 2 times 4 is 8. Minus 8. So minus 6 minus 8 is minus 14. See, I know the answer, so I was a bit worried I wasn't getting it. Minus 14 is on top. Down here is 4 minus 3 is 1. 1 squared, still minus 14. And then you're left with this, e, and that's, what's this? On top is 2, on bottom is 1. This is e squared. Minus 14 e squared is the answer of doing this. I didn't mean to do it all that way because I'm going to show you a different way now. But that is the answer we're looking for, at least for M. Let me clean this off and I'll do it a slightly different way. Implicit differentiation. It's quicker, but probably more harder to think about. Implicit differentiation just says differentiate everything. Differentiate this term. That's a product rule. That's differentiate this, multiply. Well, let me do it out. The product rule of these two is, let's see, leave the first one alone. Multiplied by the derivative of this. That's hard. The derivative of the natural log is 1 over the thing. Then you need to use the chain rule because I've cheated a little. You need to multiply it by the derivative of what's inside here. And that's just dy dx. And we want that. Now I have dy dx somewhere. Let's see. Then we leave this guy alone, natural log y, multiplied by the derivative of this. That's 2x. Put a bracket around that just in case. Plus 6 equals 0. That's implicit differentiation. Rearrange all this. We leave dy dx. We'll get this is equal minus 6 minus 2x natural log y. That's these two just moved over. Then I'll multiply everyone by y. I'll get a y up here. And I'll divide by this guy. X squared minus 3. That's dy dx. You might say this looks different than the one earlier. It is. It does look different, but it's the same. It gives the same numbers. Especially, let's see. Let me just show you. When we put in x is equal 2 and y is equal e squared, put that in, I'll get, let's see, I'll get minus 6 and minus 4 natural log of, well, let me write it out here. Minus 6 minus 4 natural log e squared. That'll cancel and leave it 2 over 4 minus 3 multiplied by e squared. In here is, like I said, this cancels and we're left with 2 times 4 is 8 Minus 6 minus 8 is minus 14. 1 on the bottom times e squared. Same answer as we got previous. This one's a little quicker, but you have to be able to do the chain rule in your head a lot more confidently. Although you had to use the chain rule the other way, so not much difference. Right, let me clear this off. I don't want to use this tiny space here. I still need to get the equation of this line here. Now, I don't want you to overthink the end of this question. Really, all we have a point, 2e squared, and then we have a slope. Y is equal minus 14 e squared. They want you to find the line. That's it. The same as we've always done. A line is equal to is the same as y is equal mx plus c. M we have right here, so we put that in. Y is equal minus 14 e squared times x plus c. How do we find c? We use the point to find c. We put in x and y, and we'll find out what c is. So y is e squared equals minus 14 e squared. X is a 2. 2 times minus 14 is minus 28 plus c. So we really have minus, let me clean that up. We have minus 28 over here. Add that to both sides. Add 28 e squared to both sides. This will destroyed, and we're left on this side 29 e squared. So there's 1 e squared here and 28 more coming. With 29 is equal to c. You'd probably get full marks there, but really don't forget to write the very last line. The very last line is y is equal minus 14 e squared x plus 29 e squared. That's the equation of this line. That's what they ask you. When they say exact constants, they don't want you to use the calculator here and have decimal numbers. They want the exact number, so they still want the e's and stuff like that in the natural logs if there were, stuff like that. Okay, that's it for question 6. If you have any follow-on questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day. In question 7, I think it's safe to say we have the hardest question in the paper. It's one of the questions that's it's quite mean in the sense that it's hard to show you what to do. There's a few spots where you have to take a jump. You have to go, oh, that looks like that, so we can move it like this. It's quite hard to teach, so I'm going to take my time. I think I'll maybe point out a few longer, weirder ways you could answer it. But I'll take my time and try and explain exactly what I'm thinking at each step. But remember, this is probably the hardest question, so it's understandable if you're having trouble with it. Okay, so what they ask, they give you this term here. They want you to express this so it looks like this. A nice little trick here to do would be to say, well, they want this to equal this. And you can now start playing around with this like you would in a different question, a similar looking. They often give you trigonomic expressions and ask you to show that they're equal. That's really what they're doing here. If you put equals, we can solve for or and alpha. You don't have to do this. A lot of students might be good at taking the leaps and the steps, but that might help you. Okay, so first of all, let me explain what we're going to do in this question. What we're going to do, and it's not clear at the beginning, I didn't know this until I jumped into the question. What we're going to do is we're going to use our rules for sine of two angles adding, and we're going to expand this out. We're going to get a bigger mess here. And then we're going to step back and we're going to think, oh, what to do next? And I'm going to notice that over here is a double angle and here has a single angle. That's annoying. We want them both to be the same. So your choices are change this to a single maybe, or change these to a double. That's usually difficult, but as it turns out in this question, that's easier. You end up being able to change this into a double, and it starts looking a lot like this side. Let me jump into it and show you what I mean as I go along. So first of all, expanding this guy out here, we get 4 cosine theta. Leave them alone. So sine of two angles, I'll cheat here. You're given these formulas. You don't have to memorize them. I'm not good at memorizing them. You're given these formulas in your pages of formula. But sine of two angles adding is just, where do I have it? It's just the first angle here, sine the first angle, multiplied by cosine the second one, plus cosine the first angle, multiplied by sine the second angle. Let me put a bracket around there. Yes, 4 cosine was outside both of these. I've expanded that out. But here's the thing. We know what sine 30 is. We know what cosine 30 is. You can double check in a calculator if you don't remember them. You don't have to remember them. Cosine 30 is square root of 3 over 2. Sine 30 is a half. So we can actually multiply this back out, and let's see, this multiplied by 4, the 2 cancels in, and we're left with 2 square root 3 cosine alpha sine alpha. And this one, the half multiplies into the 2, and we're left with 2 cosine theta, and there's 2 of them, so they're squared. That's what the left-hand side looks like. It was at this point that I noticed the trick. I guess I'll explain something you could have done if you didn't notice this. But I started to notice that this bit here, is looking a lot like sine of, it's not the same, but it's the sine of 2 theta. Looking a lot like that. And also this here looks a little like cosine 2 theta. So I thought, okay, and I want 2 theta. So that's the next step I took. At this point or some other point, you could expand this one out to help you look at it. Let me do that now. This right-hand side, cosine of an angle, take away another angle, would look like, let's see, or it would be cosine the first one multiplied by cosine the second one. And then plus or still goes into both, sine the first one and sine the second one, and we still have a plus k over here. That definitely I think helps you see what we're going to do next. You didn't have to do this, but yeah, I think you pretty much have to do this unless you're so good at this question you're not watching this video. Okay, so I notice I have I have a double angle here, 2 theta, and I don't over here. I need these to be the same. So one option, which I won't do here, is to stay expanding this out and expand this out, and then just start putting things equal to each other. It should work. You should be able to get alpha and get k by just starting equating them across. But we don't have to do all that. Here's the trick. Let me write out the 2 rules actually before I go any further. These are in your formulas. We know that, let's put a little box over here. We know the sine of 2a is equal to 2 sine a cosine a. And we also know that, let's see, cosine squared a is equal to a half 1 plus cosine 2a. These are 2 formulas that are given to us. This one, you might have to rearrange it a little from what they're given. But either way, what I notice is that this bit here looks a lot like this one here. If we just had a 2, which we do have a 2. So let's rewrite that. Square root of 3, 2, which is first? Sine theta, cosine theta. Well, that's the same as sine 2 of this. So square root of 3, sine 2 theta. Okay. And what about this one? This works perfect, actually. 2 times this is the same as 2 times this. So this is just 1 plus cosine 2 theta. Now, it still might not be clear what has this got to do with this side. But let me try and line them up a little bit. I'm going to put the cosine 2 theta underneath this cosine 2 theta. I'm going to put the sine 2 theta underneath this one. It has a square root 3. It's a plus here. And it has 1 left over. Okay, so what I now can tell from this is, well, first of all, k is 1. It's the only one without sines and cosines. What I'm doing here is I'm equating cosine with cosine, sine with sine, and nothing with nothing, or number with number. And what I can tell here is what's in front of this cosine, which is just a 1, must equal what's in front of this cosine, which is or cosine alpha. So that must equal 1. Same with here. What's in front of this sine 2 theta is or sine alpha, and it must equal square root of 3. And I guess I could write in, well, no, I'll just, k is equal 1 then. We'll leave that for the moment. This comes up in maths. Hopefully you recognize this. We often do have to make a term, usually not this messy, look like one like this. We often have to do that, and we're left with something like this. So students might very quickly be able to go, well, r squared is equal these two added together. But I'll do it a little slower. The top one squared would be r squared cosine squared alpha is equal 1, and r squared sine squared alpha is equal 3. If we add these together, we get r squared cosine squared alpha plus sine squared alpha is equal to, we're adding these together, is equal to 4. Well, this is just 1. So we're just left with r squared is equal 4, or is equal 2. I know it's plus 2 because they told you in the question or was bigger than 0. But again, a lot of students, you should be familiar enough with this part that maybe you're jumping already. R squared is equal to these two added together once they're squared. So r is equal to 2. Just put that in here. Let's see. Cosine alpha is equal 1 over 2. So what's alpha equal? And if you solve it, it's equal 60. And again, we know what k is. So the answer, you're done here. This answer here is just 2 cosine 2 theta minus 60 plus 1. That's the answer to this question. Let me go through that one more time because it is there's a few leaps to take. First leap you have to take is to know, this shouldn't be a big one. You know you'd have to start breaking things apart and rearranging something. So hopefully you see sine, 2 angles, you have a formula, you want to break this apart. When you get to this line here, at this point you do need to take a leap. You need to start thinking, well, I want 2 theta on both sides, or I want theta on both sides. So what you could have done is start breaking this one down more and more, because you have a formula for cosine 2 theta and a formula for sine theta. It would have got really messy, but I think I never finished it, but I think it would work. I just glanced at it. I think that should work out. But what did jump out to me was that this term looks a lot like this one here. So I could turn this into sine 2 theta without much trouble. This one looks a lot like this. So I can turn this into cosine 2 theta. And what also jumped out at me is when I break this apart, again, I need to take this leap. When I break this apart, I would have been left with a cosine 2 theta and sine 2 theta. And then it's just a matter of equating them back together. As I said, this is, I think, the hardest question in this paper. So if you're having trouble there, I understand. Let me know in the comments and I'll do my best to help you along a bit more. For now, let me clear this off because we still have another part. The second part is 5 marks, but I don't think it's that difficult. Whereas this is 6 marks and I think it's very difficult. So although also you might be looking at this going, what are you doing? It's much easier. Looks like this, boom, we're done. Let me know because I'm terrible at trigonometry. At least I think I'm bad at all these identities. Okay, let me clear this off and we'll do part B.
If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below.
Okay, before we do part B, a quick recap of part A. We learned this term equals this term. In part B, they gave us this term and told us it's equal to 5. Hopefully you see the logic that this looks just very similar to this. So instead of this side, let's write this side and hope it works out a little easier. So this is just 3 times bigger. And instead of theta, we have 2 theta or phi, is it? I can't remember what this is called. Phi, I think. So it's just 3 times bigger. So this side is 3 times bigger. This is the same as 6 cosine. Instead of 2 theta, double this angle. It's double this angle. So it's 4 phi. Minus 60 still plus 1 equals 5. This is a lot easier to solve. It's just one equation, one trigonometric function, cosine. So let's just start rearranging. Let's see, take 1 away from both sides and divide by 6. Cosine 4 phi minus 60 is equal, so that would be 4 divided by 6, which is the same as, oh, you know what? No, I've made a mistake there. Let's see, that 1 is wrong. Can you ever think why? I multiplied this by 3. I multiplied this by 3. I forgot to multiply that one by 3. So it should be 5 minus 3, which is 2, divided by 6. So it's the same as 1 over 3. So this whole question comes down to cosine of something is equal 1 over 3. At this point, you do need to pay attention to the fact that they told you that, say, no, phi was bigger than 0 and less than 90. Now, what you can do is just solve this question. Remember, you always get millions of answers for phi when you do it. Solve that and just pick the ones that are between 0 and 90. I don't think that's the best way to do it. I think the best way to do it is whenever you have to solve with a calculator, which is right now, I need to solve this. You want to find out the limits, the range of this part. They told you what phi is between 0 and 90. I want to know what 4 phi minus 60 is between. What's that bigger than and what's that less than? It's not as hard as it looks. The smallest number they want is 0. So we put 0 in and we get 0 minus 60. So it should be minus 60 is the smallest this becomes. The biggest it becomes is 90. 4 90s are 360. 360 minus 60 is 300. So I just want to solve this between minus 60 and 300. To help do that, let's draw it. Cosine looks like this. This here is 360, 180. So where's minus 60? This is minus 90. Minus 60 is somewhere here. Where's 300? 300 is, I guess, somewhere here. And what are we looking for? We're looking for when it equals a third. That's down here somewhere. So the only answers we're looking for is maybe this one. I'm not sure. It looks like it's outside of my drawing, but maybe this one. Definitely this one we want. And again, maybe this one. On my drawing, it looks like it's just inside it. So I think we want this one, but I don't know. We better double check these two. We definitely want this one here, though. So let's solve that. Put this into a calculator. We get 4 phi minus 60 is equal to the inverse cosine of that. I think I've wrote some of these numbers down. Yeah, I have 70.529. That's one answer. But remember, there's more answers. There's minus 70. So plus 70.529. And what's this one down here? That'd be 360 minus 70, which is 289.47. If you didn't do this, by the way, you'd want to get more of these. You'd want to get like 3 either side. And because the next thing you want to do is find phi. Phi is equal to this plus 60 divided by 4. Minus 70 plus 60 is minus 10. Minus 10 divided by 4 is still a minus, like 2 something. So that one's out. 70 plus 60, take away 70 plus 60 divided by 4. And that is one of our answers, 32.6. This one looks close though, although we now know it's fine. We know this is in our range. And actually we know this one's out of our range because of this. Yeah, should have said that. And this plus 60 divided by 4 is 87.4. Yeah, let me go over that again. Because we did this work here, I know this one's out. and I know this one's good, and I certainly know the next one's out because it's so close to it. If you didn't do this work, you would have wanted to get all of these, maybe even more, just in case, and then you would have had to add 60 to all of them, divide them all by 4, and then you would have said, well, that one's out, that one's good, and this one's out. But yeah, if you do the extra work here, it should be fine. Okay, that wasn't too bad for part B, but part A was a killer. And even worse, you don't have these numbers in part B if you weren't able to do part A. Oh, that's one bit of advice I can give you. If you weren't able to do part A and you realize you need these numbers for part B, here's a tip. Make up the numbers. Pick like 1 or 2 or 3. Pick like minus 30, minus 45, minus 60. Pick 1, 2, or 3. Just make up numbers. You're not going to get any marks for the first part, but they will give you marks for the second part if you do it all correctly. Okay, that's it for question 7 and this entire paper. Thank you for watching. If I can help you out in any way, answer any other questions you have about, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day.